Hello everyone and welcome to Numpy full tutorial. Numpy stands for Numerical Python, featuring powerful capabilities such as dealing with large arrays or matrices, matrix multiplication, comprehensively accessing the elements, slicing, array selective sorting or selective search, filtering, etc. So it is mainly used in linear algebra, matrix operations such as transpose, matrix product or dot product. Dot product means element by element, okay? And also used in prominent applications such as in the artificial intelligence field, as it handles large data sets. Now, what we need to note here is the array in NumPy is different than the array in Python in general. Python array is not actually an array but a list that acts as an array when it's numerical. However, for NumPy, the array has different applications, different operations that are not applicable for native array version. And in NumPy, you can do things that you cannot do in native Python list. It's a list actually in the native language. Among the operations is casting an array from Python to NumPy array, where you can start to deal with the operations that are specific for NumPy. Alright, so here is an example of casting a list into an array. Okay, now it might not be very explicit. However, what you see on the inside, 1, 2, 3, 4, 5, delimited by 2 square brackets, is the same definition of a Python list. Alright, so it's like casting a list into an NumPy array. So how do you declare an array? A equal np.array 1, 2, 3, 4, 5. Okay, delimited by square brackets. This is a one-dimensional array. Now, for two-dimensional arrays, you have A equal np.array 1, 2, 3, 4, 5, 6. What do we have here is actually two main elements. Each one of the elements is an actual vector or array itself. So you have two arrays being two elements within another array, or an array within an array will give you something like a matrix, okay? Or a multi-dimensional array. In this case, you have a two-dimensional array. So in this example here, what you have is two elements, both of them being vectors. So each one of these, whether 1, 2, 3, or 4, 5, 6, are an element or an array, and each of these two arrays is actually an element within this larger array. So 1, 2, 3 is actually the value of A at index 0, but at the same time, this value is an array of its own. If you print A at index 0, it will give you 1, 2, 3. By the way, that would be 0 and that would be index 1. So at index 1, if you print A at index 1, it will give you 4, 5, 6. So it's an element, but this element or this value is actually an array of its own. So the second element of A, which is at index 1, because arrays start from index 0. It's a rule of thumb. So if I print A0, it will give me, as I mentioned, the first element, which is a vector, not one value, because here it is two-dimensional. Now, let's say I want to get not only the first row, and by the way, here you have two rows if we're talking in matrix language. Not only I want 1, 2, 3, but out of 1 to 3, I want specifically value of 3. You need to note that in A, you have two elements, two main elements. This one and this one. 1, 2, 3 is the first, which is at index 0. And 4, 5, 6 is the second, which is at index 1. If I print A0, it will give me 1, 2, 3. However, what if I need not the entire row, but only 3? To access value 3, which is located at the first element of A, namely 1, 2, 3, and on the third position of the vector, which is 1, 2, 3, you print A0, 0 alone will give you 1, 2, 3. Then 3 is at which index? You have 0, 1, 2. At index 2, it will give you 3. So print A02 equal 3. So at the first level, meaning that when you have a two-dimensional array or n-dimensional array, at the first level, meaning this is the first vector here, those two square brackets on the outside, you have two main elements. This is the first one at position 0 or index 0, and this is the second one at position 1. So let's say I need to get this value here, 40. You type print A. Now 40 is on the first row in the first element, which is at index 0. So print A 0. Then within 0 you get 40, which is at the third index. So print A 03 will get you 40. Now here in this example you have print A 1 3. 1 is the second element, the value at position 1, which is this vector here, 50, 60, 70, 80. Okay, so print A1 alone will give you this line, but A1, 3 will give you, out of this line, out of this vector, the value at index 3, which is 0, 1, 2, 3, 80. So A13 would give you, index 1 is this position here. Here you have this value at index 1. So at index 1, I need to access element at the third index. So A13 would give you 80. Alright, A11, that is position 1, index 1 on the outside, this larger vector, and then on the inside. So among all the elements of this, that is the value at index 1, which is 60. Another value for A entirely, that is index 0. Print A0 would give you this row. Now, inside this row, I need to access index 2. So 0, 2. 30 is at 0, 1, 2. Now, getting back to one-dimensional array, and we're talking about slicing, like sectional extraction of a vector or a matrix. Let's say I need to get, starting from the second index, all the values up to the end. So you simply type print A, you open braces, 2, colon, and nothing afterward. Meaning that, give me every element starting from index number 2. So 0, 1, 2, that is the value at index number 2, which is 30. And it will give you all the way up to the end, which is all the way to 80. Alright? Now, another example for slicing. Let's say I need to get the elements from the third index to the sixth index. Now here we need to pay attention because it might be a little bit confusing. So to get all the values starting from the third index to the sixth index, you might think that I need to type A3, 6. However, if I need to get all the values to the sixth index, the other edge, like the other part of the interval, which is here, should be 7, because always the last part would not be included, which makes sense, by the way, because if I needed all the values from 3 up to the end, I wouldn't use this formatting. I would rather use 3 and column without anything afterwards. However, when you need all the values from the third index or from index 3 to index 6, you type print A 3, 7, and it will count 3, 4, 5, 6 without the 7s. And you see here you have 40, 50, 60, and 70, and we will show you how it works in the practice. Another interpretation for that, by the way, is as if you're telling Python compiler, start from the third, go up in a way that everything from the beginning would count 7 elements. How many are 7 elements, 7 values? It would be 0, 1, 2, 3, 4, 5, 6. Start not from the beginning, but from index number 3. Now, negative indexing. You've seen the conventional indexing starting from 0 up to 7 here in this example. If I need to print the last element of A, I can either refer to the index of that last element, A7 would give you 80, or there's another way, because if you have a very large array, how can you tell what is the index of the last value? Another workaround is print A index minus 1. Index minus 1 refers always to the last value at the last index of an array. Another way to see that is looking at these indexes, called, by the way, negative indexing. It is another way to refer to the elements within an array. As we mentioned, minus 1 refers to the last value inside an array. Minus 2 is the one right before it. Minus 3 before it, all the way. So at the beginning it would be minus 8, minus something. But note that cannot start from 0 because 0 is always reserved to the first one on the left. So print A minus 2, which is this index, it would give you this value, 70. Negative slicing, another way to look at it, we can reference the values or the elements within an array using their negative indexes from the right to the left, of course, by -1 or -1, which would be referring to the last value, then -2, -3, all the way to the beginning. Of course, 0 is reserved to the first value to the left. So if I need to get the elements or values from -4 to -2, in the same way, you simply type print a -4 up to -1, which is right after -2. And the value at -1 wouldn't be included. So it will give you 50, 60, 70, which makes sense. Let's say if you needed all the values from -4 all the way to the end, you wouldn't type -1 here. You would leave it empty, okay? Because -4 column would give you everything starting from the -4 index all the way to the end. Here, however, it will give you everything starting from -4, but it would not include the value of -1. All right? Another way of slicing arrays. So let's say I need to get the values under 1, 2, 3. So here you have two-dimensional array. You simply type print a 0. 0 would give you all of that row. However, if I need to start from index 1 to the end while excluding value at index 0, you simply type 1 column. This would give you 20, 30, 40. This is how you can access multiple dimensional array. So 0 is referring to the first level, which is this value here. It's like an element within this larger array. So in large, the first array is this one, the square brackets to the outermost. Then you have this acts as an element within that array, but it's an array itself. So 0, comma. Then within that second array, I need to get all the values starting from index 1 all the way to the end. So 1 column would give you 20, 30, 40. Also, a similar example for that, I need to print the value at index 1, which is this row, not all of it, only 60 and 70. At first, if I print A1 without anything else, it will give you this entire row. That's the value at index 1. But if I need to only get 60 and 70, they sit between the first index and second index. You type 1 colon 3, not 2, because 3 is the edge. It won't be included. So to get 2, you need to type 3. It will get 1, 2 all the way to 3, but 3 closed out. It won't be included. The value would be 60 and 70.